We all do it. The day is done, the world is quiet. We lie in bed, bathed in the soft, cool glow of a screen. We scroll through one more feed. We watch one more video. We check one more message. It feels innocent, a modern ritual of winding down. The room is dark. The screen is our private window. But that bright, comforting glow is not harmless. It is a powerful signal, like a loud, persistent alarm for your brain. It is a trick on your body's most ancient clock. It deceives your mind, midday when it is midnight. This essay will explain why this habit is so destructive. It will illuminate what happens inside your eye. It will illuminate what happens deep within your brain. It will show you precisely how your most restorative sleep is lost. It will give you a clear, actionable rescue plan you can begin using tonight. Your body runs on a delicate, precise schedule governed by a master clock. This biological timekeeper is real, not metaphor. It lives in a tiny, intricate part of your brain, the suprachiasmatic nucleus, the SCN. Your eyes, even when closed, sense the environment and send light signals to the SCN. Not just any light matters most. The crucial signal is a specific wavelength, short, high-energy blue light. It pours from the screens of our phones, tablets, and computers. The danger is the mismatch between ancient biology and modern tech. For tens of thousands of years, humans lived by the sun's rhythm. The dim, warm light of fire and the coming darkness signaled rest, signaled repair, signaled sleep. Our brains responded to those cues with fidelity. Today, we hold an artificial sun inches from our face after sunset. That artificial daylight confuses the SCN, telling it to stay alert, to remain vigilant, to prepare for a day that is not coming. To understand the problem, we must first look inside the human eye. Your eyes contain more than just the rods and cones that allow you to see shapes and colors. Hiding among these familiar photoreceptors is a third, more recently discovered type of cell. These are specialized retinal ganglion cells, and they serve a different purpose. They are not primarily for vision, they are for timekeeping. These cells contain a light-sensitive molecule, a photopigment called melanopsin. This molecule is uniquely tuned to be most sensitive to the blue wavelengths of light, abundant in daylight and in the light emitted by our digital devices. When melanopsin detects this blue light, it triggers an electrical signal that begins a critical journey. This signal does not travel to the visual cortex. Instead, it travels along a direct, dedicated neural highway. Scientists have mapped this route in exquisite detail and have given it a name: the retina pathway. This is the retina-to-brain pathway that connects the melanopsin-containing cells in your eye directly to your master clock, the suprachiasmatic nucleus. When you are staring at a bright screen in a darkened room, you are sending a powerful, unambiguous message straight down this pathway. The message is simple and stark. It is daytime. The sun is high in the sky. It is a time for alertness, not for sleep. The SCN receives this signal and acts on it immediately, initiating a cascade of hormonal changes throughout your body. The activation of this pathway is incredibly efficient. Even a few minutes of exposure to bright screen light can be enough to send a potent wake-up signal to the brain. Holding a phone close to your face in an otherwise dark environment creates a high-contrast signal that the melanopsin cells are exquisitely designed to detect. The brain does not distinguish between the blue light from the morning sun and the blue light from your social media feed. To the ancient machinery of the SCN, light is light. The SCN exercises direct control over this gland, acting as its on-off switch. Under strong blue light, it sends a stop message. This is not a gentle tapering off. It is an abrupt and decisive stop. The pineal gland shuts down its melatonin factory, and the flow of this sleep-inducing hormone into your bloodstream grinds to a halt. Scientists call it melatonin suppression, a melatonin halt. Without an adequate supply of melatonin, the gentle transition into sleep becomes a struggle, tired but wired. A couple of evening hours on blue-lit devices can delay melatonin release, effectively pushing your internal clock later into the night. This creates a state known as delayed sleep phase syndrome. You find it harder to fall asleep at a reasonable hour, often shrinking total sleep time. Nightly delay becomes self-inflicted jet lag. Sleep is not a monolithic state. It is a complex, cyclical process. Slow-wave sleep is the deepest and most physically restorative phase of sleep. Your muscles relax, your heart rate and breathing reach their lowest levels. It is when your body mends tissues and fortifies immunity. Crucially, deep sleep powers the brain's glymphatic cleaning system. Pre-sleep screen use suppresses melatonin and heightens arousal, reducing time in this essential deep stage. You may log 8 hours, but they are shallower and less restorative. Following deep sleep, your brain cycles into REM sleep, vivid dreams, but far more than a nightly cinema. During REM, the brain consolidates memories and regulates emotions. When blue light fragments sleep and delays the cycle, it truncates the longer early morning REM periods. This effect is a form of REM destruction, leaving you less emotionally resilient and mentally sharp the next day. Consistent loss of deep sleep and REM leads to measurable hits to cognition, memory, concentration, and problem solving. Your mood becomes more volatile, stress tolerance drops. The nightly glow does not just steal sleep, it dismantles the very architecture of sleep. Deep within the sleeping brain, a remarkable process unfolds each night. A microscopic cleaning system, the glymphatic system, flushes metabolic byproducts. Toxic proteins form during the day, beta-amyloid, tau. Accumulation impairs synapses and is linked with neurodegeneration. When deep sleep is shallow or truncated, CSF channels do not fully expand. Cleaning becomes sluggish. One night is minor, but weeks to years create a crisis. Waste builds up, a threat to long-term brain health. Now for the solution. The science that explains the problem also provides a clear and powerful path to rescue. The answer is not to abandon technology, but to manage it with intention and discipline. The most effective strategy is a simple, strict routine, the 60-minute pre-sleep blackout. It gives your brain a clear, unambiguous signal that the day is over. Step 1. Turn off all screens at least 60 minutes before bedtime. Place your phone in another room to charge overnight. If you must use a device, set it to the warmest red and lowest brightness, a compromise. Step 2. Manage ambient light. Dim lights and avoid harsh overheads. Use warm, low-wattage lamps. Light that mimics sunset, amber and red, spares melanopsin activation and supports melatonin. Step 3. Replace screens with analog wind-downs. Read, listen calmly, journal, or meditate. A warm bath or shower can assist the temperature drop that precedes sleep. Step 4. Optimize your bedroom. Blackout curtains or mask, cool thermostat, cover stray LEDs. Create a cave-like sanctuary. Worried about missing emergencies? Use Do Not Disturb and allow calls only from trusted contacts. Place the phone out of reach or use a simple alarm clock. This prevents mindless scrolling and snooze loops. Looking at your phone in bed is a neurological trap. Melanopsin fires, the retinopathy lights up, the SCN orders a melatonin halt, deep sleep degrades, and REM destruction follows. That cascade blocks the brain's nightly cleaning, letting toxic waste accumulate. Stop screens 60 minutes before bed. Dim the lights. Make sleep a protected time.